Okay, so the first section in here in Unit 2 is going to focus on Newton's first and third laws. So these are more conceptual based laws. And so really the first thing, since this unit is focusing on forces, a force is simply a push or a pull on an object. Okay, now some of the historical aspects of the relationship between force and motion, you can see it starts way back with the ancient Greeks and Aristotle. He really developed that there was two ideas, that there was a natural motion and there was violent motion. But basically he's saying that force was needed to keep an object moving on a horizontal plane. So you need to keep applying forces for objects to move, right? Then we go 2,000 years later or so, we're talking about Galileo, right? So Galileo is basically saying that it's natural for objects to be in motion with constant velocity as it is for it to be at rest. So he's just saying it's really natural for objects to want to keep moving or to be at rest. And then fast forward, not so much in terms of a gap of 2,000 years, but 50, 60, 70 years, you have Isaac Newton. And what he really did is he took Galileo's ideas and it created a theory of motion, right? And he wrote it in his book Principia, right? Which is one of the most monumental physics books that's ever been written. And so his first law states that every object continues in a state of rest or of uniform velocity in a straight line as long as no net force acts on it, okay? And so that net force term, right? So all the forces that are acting on an object, so he's just going to say it's going to keep moving at a constant velocity or it's going to stay at rest until you basically do something to it. Okay. Now, the first law is often called the law of inertia or the law of equilibrium. Okay. And so simple enough, inertia, think about it as mass. Okay. So another way to talk about this is kind of this inertia is the laziness of an object. Right? And what do we mean by lazy? Well, it's going to resist changes in motion. So heavier objects, right? So heavier objects have greater inertia, right? Why? Because they have more mass. Okay, so it's going to be harder to get those objects to move or change their motion because they're larger objects. Okay, and then the second thing it's called the law of equilibrium. Right? Equilibrium just means balance. Now, there are two types of equilibrium that we're going to focus on here in this unit. The first one called static equilibrium, and that's that idea of objects at rest. And then there's dynamic equilibrium, which actually leads to a misconception, which is when they're moving with constant velocity or objects are moving at constant velocity. So understand that objects can be moving without being accelerated. Okay? They're just under constant velocity. Now, his third law talks about for every action force, there's an equal but opposite reaction force. And these are what we call action-reaction pairs. Right? So if I'm looking at these examples, if the one boy is pushing, right, then the other one is going to push back on them. And then they're going to go off, right? They're going to accelerate at different rates because they have different masses. And then action-reaction pairs is actually how we move in cars, right? It's not necessarily the engine of the car. It's the interaction between the roads and the tire, right? And so if the tire is pushing on the road is going to push back on the tire. And that's what creates the wheels turning, okay? And then here's a different example, right? So we know that gravity is trying to pull this space shuttle down, but also, very interesting enough, the space shuttle is actually pulling the Earth up, okay? Now, here, the mass of the Earth is much, much greater than the mass of the shuttle. That's why we don't see that motion upwards. Okay. And so that's just a weird example to show, but it's a true example that the Earth does get moved up by every object, but because the object, the Earth is much, much more massive than your standard object, we don't see that acceleration. And you could see if there was a better picture with the Earth kind of hanging out in there, you would see that the arrow is well inside the Earth versus the space shuttle where it actually comes out of the space shuttle. Okay, so those are again Newton's first